All right, guys, let's get into lesson 11.1 here, linear equations and slope. So some of our learning targets, we're going to understand the concept of slope, okay, as a ratio. It's a change in y over the change in x between any 2 points on a line. And then we will graph proportional relationships, interpret the slope and y-intercept of the graph. And we can also use similar right triangles to develop an understanding of slope as well. So let's get right into it. So our good friend here, Misty Flip, worked odd jobs over the summer and saved money to buy passes to the ski lift at the High Ratio Mountain Ski Resort. So in August, Misty purchased lift ticket prices and found several options. Since she worked so hard to earn her money, she carefully investigated each of these options. So for the ski lift, looks like there are three options. She can get a daily lift ticket for $30. They have a 10-day package, which she would pay $80 upon purchase, and then it would be $20 per day for up to the 10 days. Or she could get the unlimited season pass for $390. All right, so for number one, let's suppose Misty purchases a daily lift ticket each day she goes skiing. So let's complete the table below. So number of days to determine the total cost for lift tickets. And again, we're going with the just the daily rate here. So we're just going to be using the $30 per day. So if she went 0 days, of course she would have zero cost. If she just goes 1 day, it's $30 per day, right? So she would have the $30 cost. If she did this for 2 days, okay, it would then be $60, right? 30 each day. 3 days would be another 30, so 90. And then if she did 4 days, it'd be 120. 5 days, if they were $30 each, would be 150. And then 6 would be 180. Okay, so according to the table, what is the relationship between the cost and the number of days? So it appears to just kind of simply follow the pattern. It's going to be $30 times the number of days, right? $30 each day, so it's just kind of straightforward. 30 times the number of times, or number of days, I guess we should write. Okay, so it seems to be a pattern based on how much it costs each day. And we knew that was $30 from the table. Okay, so let's move along. All right, so let D represent the number of days, okay, for which Misty bought lift tickets, and C will represent her total cost. Okay, so just to kind of give labels to the values we were using, let's make a table this way. D for the number of days. Remember in the table was 0, 1, 2, 3, etc. And then the cost for those days, those are the numbers we filled in on the table. Again, it was 0 for 0 days. For 1 day, it was 30. For 2 days, it was 60. For 3 days, it was 90. Okay, so can we write an equation, still finishing up number 3 here, that can be used to determine the cost if Misty skis for D days? So again, if this was a variable D, what would the cost be for D days? So if we take a look at our relationship, remember, each day is $30. Okay, so the cost is going to just equal 30 times whatever D is. Okay, if we take a look in our table, just for an example, like right here, the cost was 30 for 1 day, right? That's 30 times 1. The next row, the cost was 60 for 2 days, right? 60 is just 30 times 2, and so on. Okay, so let's plot these points on the graph below, see why we think it appears to be linear. Okay, so we have the point 0, 0. For 1 day, it was $30, so I'll try to approximate where 30 would be. 2 days was 60. 3 days was 90. 4 days we know was 120. 5 days was 150, and so on. Okay, the data appears to be linear. So what does that mean? Does it appear linear to you? Okay, meaning, does it seem like it's kind of able to be plotted and form a straight line, right? If you look at that word linear, it has line right in it. Okay, it's basically the shape of the graph. Okay, so you could draw it with a ruler. It's straight, right? It's not curved. Okay, so let's keep digging into this and see what's happening here. Okay, so they want us to label the leftmost point A, and then the next points B, C, D, and so on. So this would be point A, the next point would be point B, then C, then D, then E, then F, okay, and then if we kept going, it'd be G, and so on. So according to the graph, what happens to the total cost as the number of days increases? So as we go from 0 days to 1 day, from 1 day to 2 days, from 2 days to 3 days, what does it appear is happening to the cost? Well, the cost is increasing by $30 each day, isn't it? Okay, so that shouldn't be too surprising, right? We know it costs $30 per day. So as the days increase, our cost should increase as well. So let's describe on the graph, okay, the movement. Now we're gonna do this kind of visually here. The vertical change and the horizontal change. So if we take a look, okay, at point right here from A to B, the vertical change to get from point A to point B, the vertical, right? Vertical is going to be up and down in the Y direction. So from point A to point B, the vertical change was 30 units. Okay, the horizontal change, horizontal is like the X direction from left to right. From point A to point B, the X went from 0 to 1. So that was a change of 1 unit. Okay, how about from B to C? From B to C, the Y values went from 30 up here to 60. So from 30 to 60 is a change of 30 units. The horizontal change from point B to point C, the X's went from 1 to 2. That's a change of 1. Okay, what about from C to D? Okay, the vertical, the Y values went from 60 up to 90. Okay, that's a change of 30 units. The horizontal change from point C to point D, if you look at the graph, it went from an X value of 2 to an X value of 3. That's a change of 1. Okay, so hopefully we see that pattern just kind of keep going and going and going. And that's what makes this thing linear. It has that constant, we're going to call this a slope, like the steepness, okay, or how diagonal it is. And that's why it is a linear function. For when we first graphed this thing, right? We kind of already drew the line through there. I guess I was thinking ahead. So the slope we can see, okay, is 30, right? It's going up 30 over 1. Up 30 over 1. Okay, now the equation that we wrote in number 3 here, when it asks us to write the equation of a line, we wrote it down here. Remember, the cost always equaled 30 times the number of days, okay, based on our table of data that we were using. Okay, so you see the 30, which is the slope, is going to be whatever gets multiplied by, in this case, the x variable. Okay, and our y-intercept on this problem, this thing crosses the y-axis at 0, 0. Okay, so what we're going to see when we get down the road is there could be sometimes a plus or minus something after the equation. In this case, it would be plus 0 because there is no value for the y-intercept other than 0, I should say. So we'll get more into that later. They're just kind of leading to the way we're going to write equations for lines. It'll always be the slope times the x variable and then plus whatever the y-intercept is. So more on that later. Okay, I just want to introduce the concept. So those movements that we just traced in item 7 can be written as ratios. Okay, ratio is basically just a fraction. Okay, or it could be written as you see on the side box over here. We could write it as like 1 to 4, but it could also just be written as 1 to 4 like that as well. But anyway, so for our problems, if we write it as a ratio in the form of the vertical change over the horizontal change, if we do that from point A to point B, and remember for all of these, the vertical change was 30 and the horizontal change was 1. From B to C, the vertical change was 30, the horizontal change was 1. Okay, and again, that was the case from every point to the next point. It was always going up 30 and going over 1. Okay, so that vertical change can also be described as the change in y. Okay, that's just another way to say vertical change, right? Y is vertical. The horizontal is really just change in x. So when we write our ratio as vertical change over horizontal change, that's really just equivalent to saying the change in y over change in x. Okay, and that's what we're going to use when we start using this word slope, okay, and throwing slope around like steepness. It's going to be the change in y over the change in x. Okay, let's take a look. If we go back to our data from item 4, okay, can we determine the change in y and the change in x for each movement below? Okay, so to go from point B to point E, okay, so let me get the table drawn up again just so we can see this. All right, so magically, there's the table of values that we just used before. I put the blue letters there just to represent, remember how we labeled the points A, then point B, then point C, and so on. So instead of going back to the graph, let's just use this table and see if we can answer these questions. So to get from point B to point E, so I'm doing this right here. To get from point B to point E, right? Let's just highlight those. So point B was 1 day, it cost $30. And point E was 4 days, it cost $120. The change in y over the change in x. Let's think about that. So from point B to point E, the y values, okay, again, remember that the x was the days, the y variable was the cost. So the y values to get from 30 up to 120, that changed, that went up. You can always find the change by subtracting. So 120 minus 30, it went up $90. And the number of days, the change in x went from 1 to 4. That's a change of 3. Okay, 90 over 3. How about from A to E? So from A to E, the y values went from 0 up to 120. So that's a difference of 120. The x values went from 0 to 4. That's a difference of 4. Okay, what about from B to A? To get from B to A. So here the y values go from 30 down to 0. So the change in y went down, so it went negative 30. The change in x went from 1, it went down to 0, so it went down 1. Okay, so the idea here is if we look at each of these, and we simplify them a little bit, okay, 90 over 3 is equivalent to 30. 120 over 4, 120 divided by 4 is 30. Okay, negative 30 divided by negative 1 is 30. It's all coming back to this 30 number that we've been using the whole time. Fractions, different numerators and denominators, way back here. And okay, so describe the similarities and differences. So they were all different numbers, right? They had different, okay, but they were all definitely related, right? They all actually equaled 30 when reduced, right? So they were all the same. Okay, again, that number, that 30 is what we're going to be calling the slope here. Okay, so what are the units of the ratios created? We were doing the change in y over the change in x. Okay, remember on our graph, when we plotted these, x was the number of days, and y was the total cost, and our graph did something like this. It had these points that were in a linear pattern. Okay, so the units, when we did the change in y, okay, here's a fancy symbol, change in, you can use a little triangle, it's called delta, just a little abbreviation, okay, change in y over change in x. So the units on that, the y units, okay, the unit for the y variables is cost, okay, and the unit on the x variable is days, okay, so the unit on this is just going to be dollars over days, okay, or in other words, cost per day. And again, that equaled 30, right? And that was what we knew it was. That was given to us at the very beginning of the section. Okay? All right, so the last thing we can look at, this ratio of change in y, and we saw this. The ratio of change in y over change in x between any 2 points on a line is constant. It means it never changes. Okay, let's use the diagram below and what we know about similar triangles to explain why the change in y over change in x are equivalent. Okay, so let's think about this. So imagine here's our line, okay? From W, it goes through point V and goes through point Z, and a line will keep going, of course. Let's think about these ratios. So to get from point W, let's do these in red here, to get from W to V, okay, looking at the diagram, the ratio, the change in Y from point W to point V, we see that change in Y is 3 units. The change in X from W to V is given as 5 units. Okay, now if we look at point W to point Z, W to Z, we see that change in Y from there to there, that vertical change is given as 6 units. And the change in their X direction, the horizontal change, is 10 units. Okay, and we can see that those are equal to each other. Okay, they're actually very equal to each other. They're the exact same thing. So this ratio stayed constant because V is a point on this line. So any 2 points on that line are going to share that same slope or same y-intercept. So we're thinking about it right here. Okay, so here's where they formally define what we've been talking about. So the slope of a line is determined by that ratio between any 2 points on the line. Okay, the slope is a constant rate of change. Okay, it's also sometimes called the average rate of change. Okay, when you guys get way down the road in the pre-calculus and calculus, talk about that a lot more too. Okay, so all linear relationships have a constant rate of change. If something, if the graph of some data is a line, it's going to have a constant rate of change. Okay, the slope of a line is what determines again how steep or flat the line is. If the slope is a larger number, the line's going to be steeper, and we will see all of this stuff. Okay, this other one here, the Y-intercept. Okay, to intercept is like where you touch something. So the y-intercept of a line is the point where the line crosses the y-axis. Okay, and we're going to take a look at that in just a second here. All right, so let's go back and draw a line through the points that we graphed in item 4, and then we're going to use our graph to determine the slope. Okay, so let's just finish this up with item 13 here. We want to draw a line through the points. We did that, use the graph to determine the slope and the y-intercept. So we did that. So the slope again, remember this new term, the slope was 30. That was how much the y went up each time the x went up 1. Our y-intercept for that case was 0. Okay, and again, just graphically, that was because, so the line was doing something like this. So when x was 0, when the number of days was 0, the y-intercept there was 0. The cost was 0. Okay, and our equation was that the cost equals 30 times the number of days. So the slope is always what you multiply the variable by. And then since we didn't need to have any plus or minus anything out here, it was like a plus 0, that's where your y-intercept will show up. And again, we'll talk a lot more about that down the road here. Okay, so that's an intro to slope. If you always just remember, it's the change in the y value over the change in the x. That is what slope will always be. All right.